Good morning. Happy Monday, everybody. How are we this morning? Hello. Hi, Cass. Hi, Caitlin. Hello, everybody. Hi. So nice to see everybody. My husband came in this morning as I was getting ready and goes, it was like minus 14 or something, or minus 10. And I'm like, that's just ridiculous. It's crazy. It's a cold morning. So lucky you guys are in some place nice and warm, which is awesome. You went for a walk this morning. Good for you. Do you have a dog, Caitlin, or just decided to go for an early morning walk? I know, it's so cold. It's crazy. Yeah. Yeah, it's funny. Well, it's not funny, but you watch people with dogs and you're just like, suckers, my cat doesn't need a walk. So that's awesome. How was the weekend? Everyone have something to tell me about their weekend at all? I haven't seen you guys since Wednesday, so it's been a while, but anything spectacular happen for anybody? I'm going to use my Darth Vader mug. Yeah, you see him? Yeah. I got some warm tea in there. It's hot. Yeah, how about the weekends? Anything special? It was good. I was writing, getting close to finishing the first. Awesome, Emily. That's good. Is that a class assignment or just a book that you're doing for yourself? A bit boring. That's okay, Cass. Enjoy that, because when you get a little bit older, life gets so busy. You really want those boring days. Christmas tree shopping for that's awesome. So you're going to get that going soon. Solve a Rubik's. Oh, good job. I haven't been able to do that without moving the stickers. I gave up after a while. Went bowling. That's awesome, Jess. You're still down with your dad, right? I think so. You stayed inside. That was a smart idea. Book you're doing for yourself, Emily. That's cool. Oh, cool. Can you share what it's about at all, or is it a surprise, or you just don't want to share what your book's about, Em? Yeah, so you can't cheat. I like the one with the stickers because you can totally move it. -3, yeah, it's a little bit warmer there than it is for here. Okay, Slade, $100 gives away. That's awesome. Anyone can use money. That's awesome. Cool, cool. Cool. And my weekend, it was nice. I had a friend's birthday thing I went to Friday. She and I just had some appies and stuff. And then a friend of mine and her husband, they both quit their jobs. And since the end, when did they quit their jobs? They ended in May sometime, I think. And then they went to the island, hung out with some family and stuff. And then by mid-June, they started a cross-Canada trip. And her husband's like this massive, loves bike riding. Like, some people are just designed to do certain things, and he's designed to go bike riding. And so he rode his bike across Canada. And they would have little check stops. She had her vehicle with had all the stuff in it for camping, and then they would camp along the way. And so they've been gone since kind of the middle of June. And so they went all the way across, and then when they reached the Maritimes, they spent some time there, and then they kind of not snuck in, they did it legally, but they came in through the States there over on the east side, and then they kind of made their way across. So he had ridden like 5,000 kilometers or something like that. Like, it was something ridiculous how much. He could not eat enough food to maintain his weight, because he was burning so much food and calories, so much calories during his bike riding, that he just wasn't able to eat as much food. So they ended up trying to get a lot of takeout food because it has high calories in it. It's not healthy for you, but they couldn't figure out what to feed him to help him like maintain his weight and stuff. So he still lost some weight, but really cool experience, really cool pictures and everything. And then, so long story short, that's my squirrel moment. So they're in town right now. So they arrived about 2 weeks ago. So on Friday, she does like a little dinner, ladies' dinner club or whatever. So we did that. So I was able to see her, which is kind of cool. And then what they're doing is they're going to go to Thailand. And they're going to go there, and they're going to stay, it was like 3 months on this island, I think. And this island is sort of, part of it is a big, massive animal, like dog sanctuary. And you have a couple options. You can go there and stay there, and I think they give you like a really cheap rate, and then you volunteer, but it's kind of like a job. So as much as you're volunteering, you have to be, start at 7:30, and you volunteer to like whatever time, 5 hours or something like that. And then they provide you room and board, I think. Or what you can do is go into kind of where you stay somewhere around there and then you go and volunteer when you want to and everything like that. So they're going to be doing that, which is kind of cool. And then they're going to go see an elephant sanctuary, which is actually a true sanctuary. It's not where they train the elephants and stuff like that. So it's going to be really, really cool. Yeah, so that was my Friday. So Emily, your book is about a girl and she loves books and her favorite character from his book. Oh, that's kind of cool. That's a neat little story. Yeah, my godparents have done the U.S. Oh, they've done that too. Yeah, they actually ran into a guy a couple times. They ran into him somewhere in BC, and then later on they did different paths, but then they run into him in certain locations, kind of like not purposeful meetup points, but they would. So that was kind of cool. Yeah, so that was kind of neat. And yeah, anyone else have anything to share about their weekend at all? Anybody? Okay. So let's have a little peek at how things, they didn't bike the whole thing, but they did. Yeah, still, that's just crazy. They're actually going to go to Europe as well. And apparently from Germany to Venice, apparently there is, like the Danube River is there. There is a purposeful made bike path that's paved and everything, and it's just meant for bikes, and it goes along the river. And I guess there's little towns along the way, and it's meant to be like a casual bike ride, and then you can stop and you can stay in all these little places along the way, or you can do it in a couple days or something like that. So, yeah, so they're doing a little bit more biking, so not my thing, but yeah. Awesome. Okay, so it's Monday, time to get back to work. The kitty cat is studious and ready to go. So this week you have Military Museum is happening on Tuesday from 1 to 2. So this would be really important for you guys to kind of have a little bit of a background about what Remembrance Day is all about. Very, very important that the generations, your generation and generations coming up, have that appreciation for what you have right now and what the cost was in order for you guys to get that. So, so that's happening on Tuesday, so it'd be great if some of you guys could go to that. And then Friday is a continuation of the martial arts training. So that's from 10 till 12, and you're using gun karate and jujitsu. You have to say it like that. You gotta. All right. And today's plan. So we're gonna go have some and see if there's any questions from last day's work on tangent law. We're gonna look at sine and cosine, and like I said, procedure's the same. To do both of these, there's just a little bit of differences between them. If they were exactly the same, then they wouldn't have changed their name, obviously, right? So, so we're going to look at that, and then I'm going to give you guys some work time. We're going to do some back and forth where I'm going to like have a little break. You guys go and do some work, come back, and then that kind of thing. And then there's one worksheet that's going to be due for Wednesday. You guys have the quiz today. And make sure that you have your test done for Wednesday. So it was opened up on Wednesday. Not very many of you have asked to get that done, so you guys need to be getting that done soon, please. Please, pretty please. Okay, so let's get some questions. So does anyone have any questions from last day's work at all? So you guys had this assignment right here. Any questions, anybody? How did we do? Hopefully you guys were able to figure out your calculator and get that all done. Okay, 2A. So that's just a matter of typing in. I got the calculator figured out on the thing here. I had to go and look at the user guide to figure out the calculator, and I just had to, it showed me how to like navigate through all the menu when there's not easy thing to do. Okay, so this one you just have to type in. Oh, that's not what I wanted to do. Stop it. So all I have to do is type in. Oh, that's not going to show up too well. I don't think I'll be able to use this because my screen isn't showing the bottom part of this. No, I can't use this. Anyways, what you would do is type in decimal 6532. So you type in decimal 6532, hit the second F button or shift. So on this one, it's a shift right here. Mine on my calculator is a second F. Some of you guys might just say second. So you hit the second F and then you hit tangent, and it gives you degrees. So I don't know, Merle, maybe later you can help me see if I can figure out how to get this to show like that properly. So yeah, so you just hit those numbers and get the answer. Does that help you, Alexis? You just type in the decimal number, hit second. And like I said, some of yours, this one I believe I have to hit, this one I think I have to hit second, tangent, and then I hit the numbers. So I think on this one I have to do that first. On my calculator that I have in my hand, that one I just type the numbers in first and then hit second. Okay? So Alexis, I need a response, my dear. Was that good for you there? Okay. Any other questions on how to figure this out? On the worksheet we had to hand in, I had 2 questions. Perfect. So I can answer those in a little private session. Did you hand it in already? So here's the thing. So it's just like the stuff that you hand in is for me to see how you're doing. It's kind of, it's not like a quiz, but it's just a worksheet to see how your work is going and for me to kind of see where you guys are all at. If I see that you're stumbling on a certain question, I can help you guys all with that type of question. Because you guys all have not handed that in, I can't go over and give you the answers because the people that haven't done the work will then now have all the answers and everything. So what I can do is do questions that are similar to it, or I can help you on the side. If you've already handed it in, I can help you on the side and go over the question with you and stuff like that. But I can't actually go over one of the questions that is for assignment. So if number then, yes, so Alexis, it depends on your calculator, but this, like I said, this calculator that I'm using, that's what I have to do on mine. But the one that I was just doing here, I have to do it the other way. I have to do the shift, then tangent, then the number. So like I said, you're going to have to fiddle with your calculator. There is no way I can answer that for you. You just have to figure that out yourself. Gave me the same answer, did nothing, or gave me the same number, it did nothing, or did I hit, you probably hit something wrong, my dear, sorry. So on my calculator, like I said, you type in decimal 6532, okay, decimal 6532, I hit second F, I hit tangent, and the answer comes up as a different number. So you're obviously hitting something wrong, but you also have to make sure that you're on degrees. So last day, I remember I said that your calculator has to say DEG on it. So mine actually says it up on the top of the screen. It says DEG, which stands for degrees. This guy that you see online here, I actually had to go into the menu and go through a couple different areas to make sure that it wasn't degrees, because it wasn't. Because remember I told you when I was trying to make this work, I wasn't able to because it wasn't in degrees. So you're going to have to make sure you do that. So Alexis, unfortunately, if you want to pop in if you're still having issues, but I can't help you because you're going to have to kind of fiddle with your calculator there. Okay, I couldn't find the answers to of the word problems. I understand the rest. Okay, so Caitlin P, maybe if you've handed it in, we can kind of look at those in a second. Okay, any other questions from this? Hopefully it was just a matter of dividing a fraction like this. So that's a ratio as well. It's just in factorial form. Having it as a decimal, converting it into degrees, doing that kind of thing. 5A and B. Okay, so, oh, I didn't take out my little pen, silly me. Okay, so 5A and B, so all you guys have to do with these is you take this, and what's the fraction, 5/8? What's the mathematical kind of process that I have to do once it's 5/8? What do I have to do? Yep, thanks Sean. Yeah, it's division. So I go 5 divided by 8. So on my calculator, all I do is go 5 divided by 8, and I get decimal 625. Okay, so I'm just going to write that down so you guys can see. So it's decimal 625. And now it's the exact same process. I take decimal 625, I hit second F, and then I hit tangent, and I get my degrees, which is 32. 32 degrees, basically. Okay? That's all it's asking you to do. It says draw and label, so what you can do, so that's how you figure that out. Now, when you want to draw and label, this is the hypotenuse. Tangent is opposite over adjacent. Okay, so I don't need the hypotenuse. Opposite over adjacent, so this is going to be the 5. So if this is the angle right here, you can draw the angle wherever you want. because you're drawing the triangle, but I have to make sure that the opposite is the 5 and the adjacent is the 8, because that's how the formula works out. Okay? Yes, Josh, that's what you would do. Yeah. Yeah. Okay? So, and the other one's the exact same. It's just, instead of the 5, it's a 7. So this becomes a 7 on this one, and this becomes a 5 on that one. So it's exact same. So it doesn't matter what, which corner of the triangle you're looking at, as long as it's, you're doing the opposite and adjacent perfectly well with that angle. Okay. So Sean, is that good? Hope that's clear. Anybody else, other questions? Because I'm going to move on. We good? I had some brave souls brave the weather on Thursday and came for math help, so that was good. That weather was nasty on Thursday. It was so bad. Okay, so we are going to start taking some notes. So can you guys get out something to write with? And we're going to do that right away here. All right. So it's not going to be, we're just going to do more examples versus any kind of actual note-taking. Are you rubbing it in, Caitlin? Because it, like I said, they're so similar. They're just these little tiny differences for you to work through. Okay, so we're going to start looking at the sine law. And it has an E at the end, but they don't do that on your calculator or anything like that. You usually just go SIN. Okay, so just a reminder, you can write this down if you want. You don't have to. Tangent, sorry, I just realized that was up. Tangent is opposite over adjacent. Okay, so that's just a reminder. So the difference between the three laws is what side you look at and what side's in the numerator spot and what's in the denominator spot. So the sine, oops, is actually opposite over hypotenuse. So we actually get to start using the hypotenuse that I've been telling you to ignore with tangent. Now when you're looking at the sine law, you actually get to look at it. So if I had a right triangle like so, okay, and this is the angle I'm looking at, that's my theta. If I'm looking at that angle, I'll just give you guys a second to draw that. I get so excited to teach this stuff, I gotta remember to slow down. So if that's the angle I'm looking at, I need the opposite of that angle, which is this guy here, so that's the opposite, right? And then I need the hypotenuse, which is always opposite of the right angle, so this is the hypotenuse. So in this one, we don't use the adjacent one, which we would use in tan. Cos is adjacent over hypotenuse. Yeah. We'll get to that one today. All right, so that's the sine law. So everything is, the whole, like I said, the whole process of taking a fraction, putting it into decimal, turning it into degrees, or taking degrees, turning it into the ratio, exact same process. It's just going to be what number are you actually looking at, right? Because if you're doing the sine law, you're going to be looking at a different spot than the other one. So I'm going to give you guys this example here. So let's do this guy. So I'm going to draw the right triangle. I'm doing it the other way. Ooh, Miss Max, tricky. Okay, so I'm going to label this A, I'm going to label this B, and I'm going to label this C. Then I am going to be looking at my angle theta, which is going to be right there. All right, and I'm going to give you the numbers for all of the sides. So this is 17, this is 8, and this is 15. Now, you might get this on a question where they're going to give you all the information, but you don't need it all, right? So you just have to remember what it is that you need to be looking for sine. So with sine, so if I'm doing sine of theta, I have to do opposite over hypotenuse. And if I do that, sine theta, opposite is the 8. So I'm going to put 8 in the numerator spot, okay? And then I have to do the hypotenuse, which is always the easy one because that's the one opposite of the right angle, so that's 17, okay? So some questions want you to stop there. They just want you to say, what is the fraction? What's the fraction relation of that? And then some will ask you to go a little bit further and say, okay, so what's the answer? So in this question, because we don't know the degrees, we're going to be going from the ratio into degrees. So I'm going to take my calculator and go 8 divided by 17. So this gets me, oops, like this. It gets me decimal 4706. Because it's in my calculator already, you guys don't need to see that, but because the number, which is a whole bunch more decimal places already in my calculator, I'm not going to erase it, because the more precise you can be, the better. So I'm not going to erase this and type in 4706. I'm going to leave the whole entire thing that's written there, and then I'm going to use that, and then I'm going to hit my second function, second F, and then hit sine, because I'm doing sine. So here I get sine theta is equal to 28.1 degrees. Okay, sorry, I squished that at the very bottom there. So this is exactly what you guys did with tangent, except you're just figuring out different numbers to put in there. That's it. So that is the sine law. So that is taking a fraction, so if we're looking at a triangle, figuring out the numbers, putting it into that opposite over hypotenuse, and then converting it into a decimal and doing the second tan. How do you divide? So we were talking earlier, I can't remember, I think it was Sean. I said, what is this? This is a fraction, but what else is it? I said, what kind of math process is it? And it's division. It's 8 divided by 17. So that's how I get to that. So you guys always have to remember, a fraction is division. Okay. 28, I've just been telling you guys, go to, it depends on the question in terms of how you round. I'm just saying go to one decimal place. Some questions, if the multiple choice was 28 degrees and you had 28.1, then obviously it's 28, right? Okay. Can you see Caitlin P? I have a good trick for you, Caitlin P. Make sure you open your eyes and you actually like look on the screen. I'm just kidding. Okay. Okay, good. So I'm going to give you guys another one here that I want you to try. Let's do, no, that one has another degrees here. Okay, so let's do this. Okay, now I'm going to get you guys, I'm going to draw the exact same triangle, but I'm going to now get you a different angle to look at. So it's going to be the same triangle. Okay, so draw your right triangle. This is A, this is B, that's C. This is still 17, that is still 8, and that is still 15. So now what we did was found a tangent of angle A. I want you guys now to find tangent, sorry, that's an A, wow, there we go. I want you to find tangent of angle B, okay? So, or not tangent, what am I talking about, sorry? Sine. I've been so used to talking about tangent with you guys. I want you to find sine of angle B, okay? So this is the angle you're going to be looking at. So what are your two numbers that are going to go? So the top one is opposite and the bottom one is hypotenuse. So figure out what your two numbers are and then divide and then do the second function to find the degrees. Do not type your answer in, guys, okay? Don't put your answer on the screen. Just leave it as it is. On your paper, I'll just give people a couple seconds. I'm going to answer a message I see here. Okay. Okay. All righty. So with this one, I'm using this, so I have to go opposite, so it's going to be 15 on the top instead, and the hypotenuse, again, is still 17. It doesn't change. If it's the same triangle, same hypotenuse. So then in my calculator, I just go 15 divided by 17, 15 divided by 17. You do not have to write this stuff down. I'm just doing it so some of you guys can see my steps. So it's decimal 8, 8, 2, 4 if I was to round. I'm going to keep this on my screen because it's all the nice long numbers, and I'm going to hit the second F and I'm going to hit sine. And so when I do that, I get, so here I hit, sorry, it's second f, and then I hit sine, and this was, I divided, just kind of give you a little step there. And when I do that, I get 61.9 degrees, technically 62, which is a nice degrees to have. Yeah. Okay. Are we good? Are we good? No, you wait, Jocelyn. Just kidding. So yeah, so that's exactly what we were doing with tangent. So same thing, you're just now picking different numbers from different spots. Easy peasy lemon squeezy. Okay, so now the other one that we have to do, so now we've been working with having the sides and trying to figure out the actual angle. Now I'm going to give you the angle and you're going to tell me what that missing side is. How on our calculator do we get the decimal from the side? So Jocelyn, you got to follow these steps. So I'm just going to go over this again. 15 divided by 17. So you just type 15 in your calculator, divided by 17. That gets you this answer. Okay, that's just me rounding it. You can keep the entire number on your calculator. Then you hit second F, sine. Some of yours might say shift. Just depends on your calculator. That gets you this. There is no needing to change anything. You're going to have to figure that out yourself, Jocelyn. I'm sorry, I've kind of explained to you guys quite a few times now that I don't know what your calculator looks like, and I can't help you unless you actually come in and bring it to me if you're still stuck. So you guys know what the answer is, so you might just have to fiddle with it. It might be putting this in first and then doing the number second. It might be the other way around. Yes, the lessons are always recorded, yeah. Okay? All right. So now what I want to do with you is we're just going to go the other direction. I'm going to do another screen here. So with this one now, what we're going to do is I'm actually going to give you the angle, and using sine, you are going to try to figure out the missing side. And this is not new because we did this with tangent. Sorry, that's a degree symbol. We did this with tangent, so it's just the same process, just again, looking at different numbers. Okay, so, okay. Actually, I don't need to even, no, all I want you guys to do with this one is just in your calculator, I want you to hit sine 35 degrees and tell me what answer you guys get for that. So on your calculator, some of you guys might have to hit 35 sine, some of you guys might have to hit sine 35. What do you guys get when you do that? You just have to type in two numbers and then hit sine. Good. Yeah, so the rounding, remember with the ratio, if you're going to round, you round to 4 decimal places. So here's the number that comes on the calculator. Oopsies. 573,576, okay? So underline the digit, look next door. If it's 5 or higher, add one more, so that becomes a 6. So your answer should be that, okay? The ratio, this is the ratio for it. This is kind of what we did in this intermediate step here. So this is what we just did right now. That's that ratio, and so here we found out what this was, and then we made it into the ratio. So we went from degrees to ratio. Okay. So let's see here. I think, yeah, let's do this one here. Okay. So now that you had practice doing that, we're going to do this one here. So draw your triangle. That's an amazing triangle, by the way, Miss Mag. I know, thank you so much. I am an artist, and I take this very seriously, my artistic ability. Okay, so here we now have degrees, and we have one side, but we don't have the other side. So now we're going to do exactly what we did with the tangent, but now it's just different numbers, okay? So, reminder that sine Now we know it's 15 degrees, okay, is opposite over hypotenuse. The opposite is the x we don't know, and the hypotenuse is the 19. Okay, so this was the easier one out of the two. When the variable that we don't know with the side that we don't know is in the numerator spot, it makes it a lot easier to find the answer. The other one isn't, it's not overly difficult, it's just one little bit extra step to understand. So in this calculator, because I'm trying to figure what x is, what I need to do is get x by itself, because remember it's grumpy. It doesn't want to be. So remember I showed you guys that you do the opposite because it's dividing right now. So what I want to do is the opposite. So 19 divided by 19, I showed you guys the long version of it. You can always go back and look at that if you want to understand it. But basically, after doing the long version, this cancels out. But what's the rule? What I do to one side? What's the rule? What do I have to do? What I do to one side, I have to do the other. Perfect. So that means I got to times by 19 on this side. So when this is all finished, it looks like this. It's going to be sine 15 degrees. I'm going to multiply by that 19, and now I only have the x on that side, which is perfect because the x is now happy. So here's what I do. I go 15, and then I hit sine. And what that does is gives me a decimal answer. Okay? And then all I do is hit times 19. And so x is equal to 4.9. You can probably just go to one decimal place with the length of a side. You don't have to go to too many other than that, unless it asks for something different. So you're not going to get marked wrong from me if the answer is 5 and you put 4.9 and you didn't round it. So unless I said round to the nearest whole number. It's all the same, Angelina? Yeah, so it's all the same process. It's just a matter of making sure you pick the right numbers. If we were to do tangent with this one, I'm just going to show you. If I was to do tangent with this, I will erase this after. If I was to do tangent with this one, it's opposite over adjacent. So we don't know what that one is. So we wouldn't be able to find tangent of this angle unless they gave that to us. But it's the same process. Finding the two spots and answering it. If they gave us the number, let's say they said the number here was 10, then I would put 10 over here, and then it would be the same process. It would be 10, 15 times, lots of times, times 10 equals x, right? Same process, just different numbers, different things you're typing in your calculator. Okay? All right, so that is that one. Okay, and now I'm going to give you one that, that I'm going to get you guys just to do on your own here. No, I'm going to give you another example. I'm going to give you guys, I'm going to show you all this stuff, and then I'm going to get you guys to work on them here in a second. One second. Let me just look. Okay. All right, so I just wanted to make sure I did give some of those questions to you guys. Okay, so now this is the other one where one of the sides is unknown, but it's in an awkward spot in the fraction, in the ratio fraction. Okay, so this one I'm going to do 19 degrees here, and this is 31, and we do not know the hypotenuse. Okay, so everything stays the same. Sine of 19 degrees. Okay, let's make sure you guys get that down. Okay, so we're going to do find sine, which is opposite over hypotenuse. So the opposite is 31, and the hypotenuse we don't know, so that becomes an x. Okay, so when I showed you guys with the tangent law, I showed you the long way here. I showed you the long way of what to do. If you want to go back and look at the long way, you can. Here's the short of it. Basically, swap these two. The long way shows you how that works and everything, but if you just remember to swap those two, or you multiply, I'll show you the little bit of the long way, not the full long way, but I'll show you partial long way. So I'm going to multiply, I want the x get out of the bottom here, so I'm going to multiply by x on this side, so I get x timesing by sine 19 degrees equals 31. 1. I don't want the x there with the sign, so I got to get rid of the sign. So I divide. What I do to one side, I do to the other. So the reason why I'm dividing is because the sign and the x are multiplying together. And to get rid of that is do the opposite, which is divide. So what that does is cancel that out. So I'm left with x on this side and, oops, touching my mouse. And then I'm left with 31 in the numerator spot and sine 19 degrees in the denominator spot. So it is essentially, if you look at what I just did here, that's exactly what I just said. So that is the shortcut way, just knowing that after you do all the moving and all that kind of stuff, it's still going to get you to that answer. So it's the same kind of idea of trying to isolate x and get him by himself, but it just involves kind of having a fraction, because this one here, if you look here, there is no fraction. It's just straight sine 15 degrees times 19. This one, you have to go 31, and then you hit divide. So I'm doing 31, and then I'm dividing by the 19 degrees sine. So I hit 19 sine, and then I hit equals. Okay? And then you get your value for x. 95.2. That seems really high. No, that's right. Okay. Okay, so if you can remember the yellow highlighted spot that I have there, if you can remember that it's just a matter of just doing that. If you can't, then just go the long way, or the longer. It's not the longest way. But this shows you how you get the values from one to the other. Okay? So both these examples are showing you how to go and find the missing leg of one of the sides of the triangle. The one we did prior to that was trying to find the angle. This is trying to find one of the sides. Okay? All right. So I'm going to leave that at that. Sorry, give me 2 seconds. Yeah. Okay. All right. So any questions about that? So like I said, it's the same thing that we were doing with tangent, just different numbers. So there's no new skill here. You just have to make sure you're choosing the right numbers from the triangle and using the right law. So we can't use tangent in this because we don't have all the information. And it wants us to find sine. So, okay. Are we good? Okay. I think we're okay. Good. Okay. Perfect. Okay. So, yeah. So, Belle, I hope that, yeah, perfect. Okay. So, the next little part that I'm going to show you guys is looking at understanding when we get to sort of where you have to draw your own question, or draw your own sort of representation of what the question is. You have to understand when they use language like angle of depression, angle of elevation, and stuff like that. So what I'm going to do is we're going to do a little drawing session. We're going to do some drawing. Yes, we are. Okay, I'm going to have a little tree. Here's my tree. No, it's a pine tree. It's got a little snow on it. And it's got a little tree trunk. Okay, so there's our tree. And then I'm going to draw a pretty bird. Pretty bird. Okay, I'm going to draw my bird. It's got a beak. Oh, sorry, this is so hard to draw with this pen. Okay, there's a bird. He goes here, and then he's a bird, and he's got a big bum. And then he's got a little tail feather, and he's got feet. He's got an eyeball. Okay. Sorry, he doesn't look like he has a proper beak, but that's a beak. Okay, so there's my bird. He's on my tree. So when we are looking at this, he is on the ground, looking at the ground. So we have our ground here, and over on the ground, we have a worm. And the worm's got a smile because he doesn't realize that the bird is looking at him. Okay, so we have our little worm on the ground. So this here is to the bird. Okay, that's my straight line. This is the horizontal line of sight. Okay, so there's my bird. He's on my tree. So when we are looking at this, he is on the ground, looking at the ground. So we have our little worm on the ground. So this here is to the bird. Okay, that's my straight line. This is the horizontal line of sight. Okay, that's my straight line. This is the horizontal line of sight. Okay, so that is kind of the horizontal line of sight from where that bird is. So if he was looking straight across, that would be the horizontal line. Okay, then we have the horizontal line of sight from this guy. So this is his horizontal line of sight. Okay, so they each have different horizontal lines of sight. You better be drawing this. These are your notes. That's why I said get ready to do some drawing. Come on. Let's get some drawing going. Okay, so now we're going to use this information to try to determine the angle of depression. So this is, oops, come on. Okay, that is the sight from the bird to the worm. So that is where the bird is looking. So when he stops looking straight ahead, he's looking down towards the worm. That is the angle that he needs to do that. And this area right in here, this is called the angle of a depression, because it's kind of that whole idea of going down, depressing, kind of looking down. So that's why they call it the angle of depression. Okay, so it's going from the sight line and then you go down. So that's sort of that. Okay, and what do you think this one is called right here? What do you think this one's called? We got the worm and he's looking up, not down. So it's going to be the angle of what? I said the word earlier. Someone remember? Someone remember? It's the angle of elevation. Yeah. All right. So when you guys get questions that start talking about what is the angle, they kind of give you all these words and say, okay, we have a helicopter in the air and their angle of depression is this. That means that they're talking about what it's like from the top looking down. And then if it's talking about a rabbit looking up at the hawk, then that is going to be angle of elevation. Or if they talk from the hawk looking down, that will be angle of depression. So it's just this little pretty diagram, pretty diagram, shows sort of what that's talking about so that you guys are able to do some of the questions coming up. Okay? So I am going to give you guys a question to do with this. Give me 2 seconds. Yeah, perfect. I just want to make sure I know what I'm doing. Okay. So I'm going to show you guys an example. This one actually has words. Oh, I'm not waiting. I'm going. No, I'm just kidding. I'm just talking right now, so you should be good. So this one that I'm giving you has words, and it kind of creates an image of what's actually happening in this scene. I've already have the picture in there, so you don't have to do any of the drawing, but there are some questions where they are not going to have the drawing and you're going to have to do that, or kind of just not draw like as beautifully as I did. I know, it's masterful, but just do a quick thing and just go. You can even write the word tree. You don't have to draw a tree, right? You don't have to do any of that stuff, but this is a more fun way, funner. It's way funner to draw the tree. Okay, Caitlin T, how am I looking? Got that drawn? Almost. Come on. Okay. So I'm going to give you guys this question to do, and then we are going to do a break combo with some work. And I'm going to get you to practice some of these skills with the sine law, and then we'll do a quick little update what cosine law is, and then we're in a good place. Okay. Caitlin. Okay, I'm going to have to move on, Caitlin T, and then I'll come back in a second. I'm just going to give everybody a chance to do that. Oh, good timing. Okay, so here is this guy. So what I want you to do, I know there's a lot of writing here. What I want you to do is to draw this. So I'm going to give you guys 1 minute. You don't have to write all the words down, but take the gist of the words, and actually, believe it or not, the words and stuff and the numbers are already in the image, but I'm going to give you guys 1 minute to draw that out and get an understanding of the question. And then what I want you to do is to try to see if you can solve for that question. Okay, so I'll give you guys 2 minutes to do that. Okay, so 2 minutes, we'll be back. Okay, so sorry guys, there's not much I can do about this. It's clear on our end. It could just be how it shows up on your end, so sorry about that. So I tried to type out what it was doing, so we'll just go over that together right now. So, so basically this is a whole thing. It says a helicopter is going to go to rescue. This boat is disabled, so the helicopter's coming. So it says angle of depression. So right away what that means is that we're looking from the perspective of the helicopter. Okay, so this is the angle of depression right here. And they're saying that that depression from the helicopter to the boat is 17 degrees. Okay. If I make it larger, it might also as well make it blurry too, Slade. So we're just going to keep going. Okay. So the helicopter, it says, is flying at an altitude of 1,500 meters. That means the distance from here to here is 1,500 meters. What they did was put it over on this side because it forms that right triangle with the horizontal line of sight. So remember, I drew that for you guys and I said this was a horizontal line of sight from that perspective. So if I have that line and I have this line, the best place to make a right angle would be here. So that's why they put the 1,500 there and not right there. Okay, so I just wanted to explain why there is no line showing there. Okay, so what it wants to do, it wants you to figure out this. We don't know the flight path. We don't know how long it actually would take from them to go directly from where the helicopter is all the way straight into the boat, or if they did a zip line. Big land. Okay, so we know that we have opposite and we need to figure out the hypotenuse, so that means that we have to do sine. So we're doing sine of 17 degrees, opposite is 1,500, and the hypotenuse is the x that we don't know. All right, and this goes back to the question I just did with you where you just do that little quick substitution, where you just do that little switchy switch. So when I do that, I get x equals 1,500 over sine of 17 degrees. Okay. Let's give you a couple seconds to catch up on that. Okay. So now in my calculator, I just go 1,500 and I hit divide and I hit 17 sine, gives me the ratio, and then I hit equals. Okay, so just to say that again, I go 1,500, I hit divide, I hit sine, hit 17, and then I hit equals. So literally what it says to do. And so that side is 5,130.5 meters, something like that. Okay, and this is hypotenuse, so it's always the longest side out of all that of a triangle, of a right triangle. Okay, yay, that's good, Cass. All right. Good. So, so sorry that was blurry, but hopefully just the gist of the question, how that works, is kind of clear for you guys in understanding angle depression. If we did angle of elevation, we'd be looking at this guy here. If we did angle of elevation, we'd be looking at that going up. Can we figure out that angle right now without actually having to like do any sine or tangent or anything like that? How do I know how big that angle is? Someone tell me, how do I figure out the angle right there without having to do the sine or tangent or anything like that? How would I figure out? It's a right triangle. Think about triangles and their angles. Do we know some angles in that triangle? Come on, guys, someone knows. Someone knows. How do I figure out that other angle? I'm not giving this to you. If I need to take a minute break, I'm going to. I'm not giving it to you. How do you figure out that angle? It's a triangle. Yes, so that's a good start. So someone else besides, yes, good. Someone else besides these two, tell me how I figure that out. So if triangle, all the angles add up to 180, how do I figure out what that missing angle is? Someone besides Cass and Bell. Besides Cass and Bell, you can say it in your head but not type it. How else do I do that? Someone else besides Cass and Bell. Nice try. So think about, this all adds up to 180, guys. Everything in here adds up to 180 degrees. All the angles in there add up to 180 degrees. Look at the angles. Look at the angles. Okay, and then what else, Caitlin T? That's only one angle. Is there another angle that we know in that triangle? Yes, and then subtract this one. Good. So if you go 180 subtract 90, which is 90, and then you go 90 subtract 17, no, your numbers are wrong there. That should be 170 you're subtracting, Kirsten. Should be 180 minus 107. Yeah, there you go. Perfect. Good. Okay, it's all good. So that is how you can figure out this angle. So this angle would be 180, subtract the 90, and subtract the 17. Okay, so that's how you guys do that. Okay, so here's what I'm going to get you guys to do. I'm going to give you guys a page of questions that I'm going to get you to do. I'm going to give you guys a 10-minute break within that, and then I'm going to give you, what time are we at here? And then I'll give you guys 15 minutes to do the math. So at 10:15 or 11, I would like you guys to come back. So that's a little less than 25 minutes. And then I'll give you guys the work to do, and then we'll come back and continue from there. Okay? So you need to do these questions. Some of them are super easy because it's just a matter of typing in your calculator and going from there. This question right here, everybody, don't go to Moodle or don't do anything yet. This question right here. Question number 10, you need to go to the Moodle site, and on the Moodle site there is a plane question. It's actually about a plane, okay? Not like a boring plane question. There's a plane question I want you to do that deals with angle of elevation and depression, okay? So let me show you. So right here. So this is the Moodle site right now. And this was your homework that was due today. So right below that it says elevation, depression, airplane question you're going to do in class today. So that's the question that I'm talking about. So it's on your Moodle site. Okay, so you need to do all of these questions and then go do that one question. All right. So sorry because I just talked for a little bit here. I'll give you guys to 20 after. So let's go to 11:20. So that gives you 20. 25, 27-minute break, okay? Time to do this work, time to have a little break, and then we'll come back at that time. All righty. Okay, off you go. Oh, that clock's not right. Oh, can you put me back on? Sorry, I'm going off that clock. Sorry guys, I'm looking at a clock that says it's not been turned back. I'm so sorry, it's going to be 20 after 10. It's going to be 20 after 10, not 20 after 11. So sorry, I'm looking at a clock that hasn't been turned back yet. So 20 after 11. Okay? Okay. All right, so we're good. So I'll see you guys at 20 after 10. Okay, bye. hello, hello. Okay, we are back. Hopefully you guys got a little bit of break and got that work done. So I'm going to just get us to work in a little slowly to this. So what I want you guys to do, actually Miss Mac was silly, she didn't open this up. Oh, I can't do that. I just realized I'm screwing that up. Sorry, Miss Mac was not prepared. I thought I was prepared. I'm not prepared. I was being silly. You guys get to see me fiddle on the background here while you guys are like, what's she doing? What's happening? What's going on? I don't even know where I have it. There it is. No, we're not going to do it because I can't even find it easily. Where the heck did I put it? Oh, there it is. There it is. Okay. All right. So. Can we show this one now? Okay, so I'm going to escape that one. Okay, perfect. Okay, there we are. Okay, so last day we did this guy, found the answers. Okay, so I want you guys to now start typing in what you see the differences are between them. The bird. Yes, the bird's missing. The hat. Yeah, the hat doesn't have a little pom-pom. Okay. The tree. Yep, it's missing a little knot on the tree. The stool. Yes, it's missing a leg. The scroll's missing a scroll. Caterpillar. Yeah, there's no caterpillar. Good. What else? So that's 1, 2, 3, 4, 5, 6. Yeah, we got the leg on the stool. So that's 6 things. Got the hole in the tree. We got that. The bush behind the fence. Yes, that's number 7. What else? Bucket pattern. Yes, that's a little bit different. That's 8. His neckline on his shirt is 9. And there's one more. Yeah, we got the tassels on the hat already. There's one more. One more. Yeah, we got the paper rolls. I think there's one more. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think there's one more. Yeah, we had the hat. One more. I don't know if I can even see it. Yeah, we got the flower petal. Flower petal, flower petal. That might be it. Yes, flower petal. Nice one. You got to see that one. Excellent. Good. So yeah, so there they are. So you guys had the bird, and there's no bush back here. The tassel, his collar, missing a scroll. No knot there. Caterpillar's gone. The pattern of paint is gone. Stool and the flower. Good job. All right. Okay. So that was just a little fun little break back in. So what I've done here is given you some of the answers to the questions so you guys can double check what you did there. Sorry, just reading you guys' conversation. Okay, so double check your answers to first number 1 through 6. And then I will go over the last couple questions there with you guys and make sure you're able to get those. Okay? All right. So any questions on those? Those are just simple typing into your calculator. So the first 1 through 3 is just hitting sign and hitting 11. And then that gets you the ratio. And the other one is having the ratio and hitting the second function or the shift function, and that gets you the degrees. Okay? So question number 7. So if I'm doing sine, so I'm going to find sine of 57 degrees. Opposite is the x I don't know, and 43 is the side. So basically what I'm going to do, I'm going to do the shortcut way. I'm going to multiply both those sides together. Sorry, couldn't find my calculator. So I go 57 degrees sine, so I go 57 sine, I get a ratio, and then I'm going to hit times by 43. So I get x equals 36.1. Okay, so you guys should have that for that answer. This one is sine 64 degrees equals opposite, which is 33, and hypotenuse is the x. So what I'm going to do is switch these two. So I get x equals 33 over sine 64 degrees. Okay, so hopefully you guys should have this done. So I hit 33, I'd hit divide, I hit 64 sine, and then I hit equals. So x equals 36.7. And this one here, I'm going to change my color so you can see the difference between the questions. So this one, I don't know what the degrees or what the degrees is or what the angle is. So it's going to be sine theta. So opposite is going to be this. It's going to be 41 over 47. So all I do is go 41 divided by 47, and I get a ratio. And I'm just going to write it in here for you so you guys can see what it is. Okay, and then I hit second sine, so sine theta, so the degrees is 60.7 degrees. Okay, so hopefully you guys did okay on those ones. I'll go look at number 10 here in a second, but any questions on any of those ones? Everyone okay? Okay, all right. So what I'm going to do is I'm going to go to the Moodle site. I'm actually going to open this up for us. Okay, and so here is the question that we had to do. Now this one is not necessarily going to be a question that I'm going to do with you guys in terms of you guys had to do some conversions, but I'm just going to show you guys, and then I'm going to quickly go back to the other screen and do it there. But basically, so what's happened here is that we have an angle of elevation. So it starts here, the plane starts down here, and it goes up. And it says the angle of elevation, which means we're going from the ground up, so it's 13 degrees. Then it says, it doesn't give you the opposite, it actually kind of makes you find the opposite. Oh, okay. Hopefully she can get in soon. Thanks for letting me know, Cass. So what it says is that it goes 1,100 feet per minute. So what I need to know is figure out how far it went in 23 minutes, because after 23 minutes, this is its height. So I need to figure that out. So that's why I left this information here, because it actually gives you the number. Okay, so this is the height in feet, so there's the opposite. Now it basically wants us to figure out its flight path, like how long has it traveled from takeoff till after 23 minutes in the air. So that is going to be opposite over hypotenuse. Now the answer asks for it in miles. I'm not going to worry about teaching you guys the conversion of feet to miles right now. That's not what I'm going to stress about. So I just want you to make sure that you know the process. Okay, so if I go back to this, and so just to reiterate this, so there's my plane, tail. Okay, that looks like a frog, I don't know. Okay, so this was 25300. We don't know what this was, and this is 13 degrees. So all you're going to do is go sine 13 degrees. Opposite is the 25300 over x. And then we do that little swappy-do. Okay, so make that. Again, the long version is just longer, but it gets you to the same answer. So x equals 25300 over sine of 13 degrees. So all I do is go 25,300 divided by sine 13 and then hit equals. And you should have gotten x equals 112, so 112,444.44 feet. They wanted you to convert that into miles. If some of you guys know how to do that, you basically take this number and divide it by this number, because that's how many feet there are in a mile. You don't need to know this. I'm just letting you know that if some of you figured that out. And so the answer is basically 21 miles. Okay, so this is the answer I'm fine with accepting, because I don't expect you guys to do the conversion because I haven't even showed you that or anything. But if some of you went on the internet and figured out how to do that conversion, you should probably have about 21 miles there. Okay. All right, so that is the sine law. And guess what? Cosine law is just as easy peasy as that. Okay, so let's do this. There could be. I'm just saying the only thing on this one that I'm not going to make you do is do the conversion. That's all I was talking about. You're still going to have to do questions like that, but I'm saying I'm not going to make you convert something that I haven't showed you, or that's not the point of what I'm trying to do. Okay, so there's not going to be those kind of things on there. Okay, so cosine law. Cosine law. Law dog. Okay, perfect. So cosine law. Exact same process, just like tangent and sine, how to figure things out if you don't know the angle or you don't know the side, and figuring one or the other, okay? Same thing, but this one you just have to look at different things. And so I can't remember who brought it up and asked me, but they said, okay, so the cosine law. So let's say I'm trying to figure out, this is my theta. You guys are drawing this, okay? These are notes. This is my theta. It is going to be adjacent over hypotenuse. So cos is equal to adjacent over hypotenuse. Okay, so there is nothing new here. I'm going to do one question with you guys because it is the exact same process as the other ones. You just have to pick different numbers, or you're looking at different sides. It's exactly the same, okay? So we're going to do just one question together, and then I'm going to get you guys to do some questions on your own. I'll give you about 5 minutes to do those. And then, yeah, and then we're going to be kind of on the down end of the class. Okay, so draw this with me. Yes, yes. We got A, we got a B, and we got a C. I do not know what angle A is, but I want to find the cosine of it, okay? So I'm going to give you all of the numbers. That one is 73. It's really big. I'm writing them really big. So cosine law, adjacent and hypotenuse. I don't want the opposite. So what number do I not want to use? Do I not want to use the 48, the 55, or the 73? Which number do I not want to use in the formula for cosine? Because cosine is adjacent to hypotenuse. Exactly. I don't want to use this one because that's the opposite. I don't need opposite in this formula. So I write cos of angle A, or theta, whatever you want to put there is fine. I do adjacent, because it's A, over the hypotenuse, which is that one there. You use your calculator. You go 55 divided by 73. So just reminding you, this means division, just in case you forgot. I get a nice long number, and I hit second cos. Make sure you're always hitting the right one, because we've been doing some of the other ones, and you have because we start with tangent, I have a habit of actually trying to hit tangent, so I have to stop myself. And you get 41.1 degrees. Okay, so nothing's different. You're just figuring out what side you actually need to look at, and then making sure on the calculator you hit cos. Okay, how you doing, Jess? Are you with us at all yet? Hope you're doing okay. Okay, so with that, I'll give you guys a few seconds. I'm going to just send a message, see if Jess is doing. Because I know she's getting, thanks Cass for letting me know, I know she's getting kicked out here and stuff. So I think she's in the Blackboard, so I just want to see if she's able to get into live yet or not. Okay. So I'm not going to teach you any more about cosine. It's the exact same process, like I said. It's just making sure you know what side you're actually looking at, and then making sure you use cos instead of tangent or sine on your calculator. Okay? So what I'm going to do here with you guys is I'm going to get you guys to do these questions, and I'm going to give you 5 minutes to do these questions. all right? And then we will come back and see how you guys are doing with the cosine law. How did you get 41? Because mine didn't get that. So you probably just typed something wrong in your calculator, hun. So you go 55 divided by 73 and you get a decimal number. So you get decimal blah, 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 blah. And then you hit second cos. Okay? So that's just kind of figuring out your calculator. I think you're still having problems with that. Okay, so you might have to, okay, so I'm going to put the question back on here, 5 minutes, and then I'll talk with Jess on the side. Okay? See you guys in a bit. Oh, poor Jess keeps bouncing out. Okay. Hi guys. Okay, sorry, we're having like tech stuff going back here. That's just the way the world always works. Jess understands because she was in and out, she's out again, and she was in and out. So yeah, that's just the way technology works sometimes. So yeah, we're doing cos here. So just the first 4 questions, just a matter of typing into your calculator. And Kaylin, you're so slow. No, I'm just kidding. That's fine. We'll just go over it together. So hopefully you got at least something done there. So double check your answers for questions 1 through 4. Make sure you're good. And like I said, just a matter of typing into your calculator and going from there. So question number 5, we are doing cos. I have 13 degrees. I need to do adjacent, which is the x. Then I do the hypotenuse, 37, which means all I do is take those 2 numbers, multiply them together. Therefore, I go, what do? 13 cos times 37 equals x equals 36.1. So that's the side length of that one. Okay? And then this guy over here, we have cos of 68 degrees. Opposite, or no, we don't do opposite, sorry, adjacent is this way because this is the hypotenuse, right? So don't get that mixed up. So it's going, that's an 8. 87 over x. Remember, we can do that little switchy-do. So I get cos 68. No, I don't. Ignore me. So I get x equals 87 over cos 68 degrees. So I'll just give you guys a couple seconds just in case some of you guys did not get to that stage yet of question number 6. So then I go on my calculator, type 87 and hit divide. Then I hit 68, hit cos, and then hit equals. So x equals 3.232. It's a very long-legged side. Okay? And a new color. So I'm going to do cos. Jess is all, she's in and out, she's in and out. This is kind of funny to watch this. Okay, now I don't know the angle of this one. So stop doing that. Stop it. There we go. So I have to do, this is the hypotenuse, so then I'm going to go to the adjacent over here, which is 15 over 19. So I do the division of that because that's a fraction, and I want to get it into a decimal ratio form. So I go 15 divided by 15 divided by 19. And then I have a decimal number. I'll just write it down for some of you. Decimal 7895. Okay, it's longer, but I'm going to keep the long version, and then I hit second cos, and I get 37.9 degrees, which is darn close to 38 degrees. Okay, so there is the beautiful math upon the screen for you to enjoy. If you are getting this, absolutely awesome. If you didn't get it, but now you're like, oh, okay, now I'm getting it a little bit more, fantastic. If you're still struggling, please make sure you stay after with me and I can help you with some questions, okay? So, that is all I'm going to do with you. I know, it's a little crazy. Just to double check, yeah, just had to double check. I didn't have something on that screen. So I try to make like pages anticipating how many I'm going to need, so sometimes I don't need as many as I did. Can we see the answer for 7 again? Oh, sorry, can you take me off the screen so they can see the whole thing there, please, Merle? Thank you. There you go. Magique. It is off. It's like Merle the Marvelous. Marvelous Merle. Removed me from the screen. He's magnificent. He's magical. All right. I know. Okay. So what I'm going to do is I'm going to show you what the plan is for today moving into Wednesday. You guys have 2 practice ones to do. One's a practice on sine, one's a practice on cosine. And then you have one that combines both of them together that you have to hand in. Again, just like I always tell you guys with the practice ones, you do what you want to do with the questions. So this is the one that's for practice for sine. So some of it's just calculator work, some of it actually is you have to write out and kind of put it all there. So yeah, so that's that one. I don't think there's much to explain on that. And then the second one that's for practice is this one's on the cosine. So same thing, just you're using just different parts of the triangle or using a different button on your calculator. Okay? So hopefully that's all right. And then the last one that I want you to hand in, you only have to do the 3rd and 4th page. You only have to do the 3rd and 4th page. No 1 and 2. You don't have to do 1 and 2. So I'm going to scroll and show you. You don't have to do this. 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 Okay, so page 1 and 2 you don't have to do. You start where it says example and you start working from there, and it uses the cosine and the sine law. Okay, so make sure you guys do not do 1 and 2 and go, I'm stuck, I'm so stuck, I don't get it. Okay, because you don't have to do that. All right, so any questions on those 3 things? We're not done. Don't go to Moodle yet. Just any questions there at all? Because I'm going to pop over to my PowerPoint. Okay. All right. Okay. So today, you guys are going to need to do the quiz as soon as I am done here with you guys. You guys are going to do a quiz. It's just a little bit on the tangent law, not on sine and cosine, but just on tangent. So just reminders, you're doing on your own, no material. I would like you to get it done. I would do it now. It is 10:45. You guys have plenty of time to do it now before the 11:30 technical end of class. And make sure that you have it finished so you're not forgetting to do that, okay? And while the stuff's fresh in your mind. So tangent's exactly the same as sine and cosine. You're just using different numbers. I think there's only 5, but I'm not sure, Belle. Sorry. We'll get to that, yeah. I know, Jess. I'm sorry, hon. Okay, so what's next? You have 3 worksheets to do. 1 of them gets handed in. So 2 are technical practice. 1 is handed in. It's due Wednesday. The quiz is today. It is remember, because we have Remembrance Day coming up on Monday. So I've made the password for this remember. Make sure all your work is due, and you have to have your test done by Wednesday. So some of you guys, most of you guys haven't even accomplished that yet. You guys need to get that done. So some of you have work to do, and then you need to get that test done. So please remember that a typical student puts in 5 hours a week or 5 hours a day at school, and then they come home and do work. So despite the fact that you're with me for an hour, 2 hours, 2.5 hours, whatever it is, you still have so much more room to be doing some work, right? So just keep that in mind. So some of you guys have some catch-up work to do because you just need to be putting a little bit more effort in or anything like that, okay? So I'll be appreciative of the less time, but you still have to be putting in the amount of time that's needed, okay? So that is the task. Thanks, Val. No, you're working really hard, Val. It's nice to see. Any questions? So password is remember. I think I have it opened for you guys. You guys can take that right away. 2 practice worksheets, and then make sure you get your test done. And then 1 of the worksheets has to get handed in out of the 2 after the 2 practice. Okay, I'm going to stay on. I'm going to take about 5 minutes. I'm going to go to my office. I'm going to leave Magical Merle, and I will stay on. So if you need me to help you with your calculator, if you need me to help you with any of these questions, stay on Blackboard, and I will be able to help you guys at that time. Don't stay on Blackboard if you don't need help, because it happened last time. I'm like, hello, are you needing help? And they weren't responding to me. So just go off of Blackboard if you don't need help. Your calculator's fine. You got everything worked out. But if you do need some help, do that. Okay? All right, so guys, you're awesome. We have plugged away through all the different laws of trigonometry. So good job, and I will see you guys on Wednesday. All right, bye everybody. Bye Cass. See you. Bye Bryn. Stay on if you need some help. Bye Alexis. Bye Danica. All right.